In this video, I'm going to show you how to solve the ALEKS problem called Finding Isotope Mass or Natural Abundance from Atomic Mass. So this problem is going to give you a data table, and in this particular version of the problem, I'm being asked to calculate the natural abundance of these two different isotopes of antimony using whatever data you need from the ALEKS periodic table. The ALEKS periodic table is going to be located right here, and it is really important when you're solving this problem that you follow that guideline and you use data from ALEKS's periodic table. I'm not going to do that. I'm using data from my own periodic table, which maybe could cause your answer to be incorrect, but I'm going to do it anyways. So the data that we need from the periodic table is the average atomic mass. That's this big number down here, 121.760. I'm just going to kind of write that off. Let's see, put it right there, 121.760. So you're going to need to get that number from ALEKS's periodic table, not from a different source, because you want to make sure you get this problem correct. The next thing that I'm going to do is show you how to use this information. So no matter what version of the problem you're being given, because some of these problems are going to ask you to maybe calculate one of the masses of the isotope instead of being like mine, the natural abundance. So what I'm going to do is I'm going to call this isotope number 1, and I'm going to call this one right here isotope number 2. The mass times the abundance of isotope number 1 plus the same for isotope number 2 is going to add up to the number that you get from the periodic table. So we're going to say the mass of isotope, I'm just going to do subscript 1, so that means the mass of isotope number 1, that's this right here, times the abundance, I'm just going to write abundance of isotope number 1, plus the mass of isotope number 2, times the abundance of isotope number 2. So here's the mass of isotope number 2, and here's its abundance. That is going to be equal to whatever you get off of the periodic table. So this is going to be periodic table number. And you can just, depending on what version of the problem you get, you can just fill in whatever you actually know from the problem. So for my version of the problem, I know the mass of isotope number 1. I know 120.9, but I don't know the abundance of isotope number 1. And I know the mass of isotope number 2, that's 122.9, but I don't know the abundance of isotope number 2. And I do know the mass from the periodic table, 121.760. You're always going to know this number because you're going to look it up. Now, all that we have to do is just solve for whatever number you're trying to figure out. In my case, it's these two abundances. This is actually pretty tricky because these are two different numbers. So like, let's say we're going to use math terms. Let's call this one an X and let's call this one a Y. So instead of having these abs in there, we can just have an X and a Y. It makes it look like a normal math problem. Depending on how much math you have done in your life, you might right away see we have an issue here. We have one equation, and that one equation has two different variables, which makes it impossible to solve. You cannot solve a single equation that has two different variables. Every variable has to have its own equation. So what we're going to have to do is rewrite this equation with only one variable, either only X or only Y, but we can't have both X and Y. Now that's okay, it's not quite as hard as it seems. We know up here that the natural abundance of all of our isotopes always is going to add up to 100%. So that's going to help us write X and Y, in different terms. We know from this that X plus Y is always going to equal 100%. So that means that we could say X is 100% minus Y, or the other way around, Y equals 100% minus X. And we're going to use that in this particular table. So I'm going to use this relationship right here. Instead of saying X, I am going to say 100% minus Y. So instead of saying X, I'm going to say 100% minus Y. And now I have an equation that has only one variable, Y. And now I'm ready to solve. Now the next thing that I'm going to do is get that percent into decimal form, and that's just like my own personal preference. I don't like to work with percentages when I'm doing math. So to convert your percent into decimal form, you just have to divide it by 100. So 100 divided by 100 is just 1. And to me, this is just an easier way for me to solve the problem. But you could actually have just, you absolutely could have left it in this form and proceeded, and you'd be fine if you're comfortable with that, which I'm not. So next thing I'm going to do is expand this portion out. I'm going to go 120.9 times 1. And then I'm also going to go 120.9 times negative y. And then I'm going to do this math over here, 122.9 times y, and that is equal to 121.760. Next thing that I'm going to do is combine the like terms. So I think what I'm going to do first is subtract 120.9 from both sides. And that is going to give me, I'm still going to have these terms over here. For now, I'm just going to keep writing that out, 120.9. What did I do there? That minus sign shouldn't be there. 220.9y plus 122.9y is equal to 121.76 minus 120.9.86. And next I'm going to combine these two terms right here, 122.9 minus 120.9. Oh, I didn't need a calculator for that. 2y equals 0.86. And now I can solve for y, which is, didn't need a calculator for that either, 0.43. Remember that up here in this step, when I went from my step number 1 to my step number 2, I got rid of the percentage by dividing by 100. So down here, I have this in decimal form, 0.43, which is multiply it by 100 to put it back into percentage, 43%. And that is my y. Actually, I'll leave this there. That's my y. So we'll fill this in. Y is 43%. And x is 100 minus y, which is going to be 57%. Now, before we hit check, we should double check to see how many sig figs it wants. It says it wants 3 significant digits for the answers to all of these. And my calculator gave me exactly 43%. So that means I'm going to add a 0.0 to both of these so that they have 3 significant figures.